For the last lesson in this unit, we're going to be discussing parent functions and transformations. Now, you've probably been introduced to the idea of a transformation in geometry when you took a two-dimensional object or shape on a coordinate plane and then you either did a translation or reflection or rotation. So that's probably a concept that you should be familiar with. We're going to extend on this and we're going to focus on a handful of different types of transformations. We're going to work on translation and reflection, which you should be familiar to you, and we're also going to work on something called a compression or a stretch. And you may have heard the term dilation or scale factor in geometry, and that's how that relates to compression and stretch. And so what you're going to find in algebra is that we have a number of different what we call families of functions, and each family of functions has a single basic function that all movement of transformations work off of. And you can see here our parent linear function is y equals to x. And so I'm just going to take a quick second and go to the calculator and show you some basic ideas of what we mean by transformation. So if you're on the calculator and you want to get to the calculator, you can hit the letter B, or I can hit the calculator function twice. I hit it too many times, and it goes to the graphing part. Now, if you notice, the graphing calculator has f of x, or f1 of x, meaning the first function. Remember from now on out that f of x is the same thing as y. So we're just replacing the y, and you remember from function notation, that's all we're doing. So I'm just going to plot y equals x, or f of x equals x. So all I need to do is come down here and hit the x on the keyboard, and then hit enter, and it'll actually graph that line for me. Okay, so now what I want to do is I want to show you and compare that. I'm going to move that label kind of out of the way. Compare that to another one. So if I want to bring up another entry screen for another graph, I'm just going to hit the tab button. I'm just going to go ahead and I'm going to do another one. I'm going to do 2 times x, and then I'm going to hit enter. You can see that by multiplying the original function by 2, we've made it a little steeper, and so we've basically stretched it out. That's a vertical stretch, and we'll get to that in more detail later. Also, one last thing, I'll do one more. I'm going to hit tab again, and then I'm going to just add one. So I'm going to say x plus 1, so we see what that does to the original function, and you can see that it went up 1. So you can see that each of these changes to the original function does something completely different to it. Those are transformations. Now, these transformations will stick with us throughout the year in Algebra 2, and you will need to get to know these transformations very well and how they affect the functions graph that we are working with. So let's take a look at our first one. We're going to start with translation. And so a translation, as you can see, is just a shifting or sliding of every point on the figure. So we are just going to be shifting or sliding left to right, or up and down, or a combination of both. We may be able to shift a function to the left and then up, or to the right and then down, or vice versa. And so it's very important that you understand how a translation works. And so you can see here in the first one, a vertical translation is when we add a value to the entire function, the entire base function or parent function. Now, we're going to be using K to represent vertical translations for the rest of the year. And if you look at the second part of this, H is a translation that actually moves it horizontally. It's going to move it left or right. So H and K are going to be a part of your terminology of translations all year long, no matter what we're working with. Now, one thing that you need to be aware of, whenever we add or subtract a unit, a vertical translation, it does exactly what is suggested. So if it says plus 3, we're actually going to move up 3. If it says minus 2, we're actually going to move down 2. However, with the H, it actually does the opposite of what we have given. So if it says plus 2, it's actually going to go to the left 2, and if it says minus 1, it's going to go to the right 1. So a couple things that you're going to need to pick up on as we go through this. So let's take a look at our first sample problem. go ahead and read sample problem 1 and then plot the original point and then do the translation and answer the following questions. Okay, so if I start with -2 and a +5, I start right here, and it says to translate it 3 units left. So I'm going to come over 3 units left and then 2 units down to get my resulting new point. And so my resulting point is now -5, +3. When you translate the point left to right, how does it change the coordinate on the point? Well, when we do left to right, it actually changes the x values. And then when we translate the point up or down, this actually changes the y values. And that is the first video. We're going to stop right here on translation, and so we'll move on to reflection after that.